Hello everyone and welcome to another technical overview video of Black Square's Starship. When Starship was first developed in the 1980s, it came without GPS positioning, but this was no problem for the clever avionics engineers of the time. Starship's avionics suite was designed to monitor all available navigation sources to produce a constantly shifting position estimate throughout the flight. This position estimate is informed by the aircraft's initial position at startup, nearby VOR and DME stations, VLF navigation receivers, and aftermarket GPS position augmentation. To fly with only the original equipment, you can disable the GPS position augmentation from the sensor status screen of the CDU. We can see which sensors are currently being used on the FMS position screen. If we've deselected a sensor or the signal it's receiving does not comport with the current position estimate, it will be ignored. Since most of the time you'll be flying with GPS, GPS satellite position integrity is also simulated and affects the position estimate. In the 1980s, a global navigation service known as Omega, which was operated by the United States Coast Guard, provided relatively accurate positioning around the world. These signals were broadcast from only 16 transmitters in the very low frequency VLF spectrum. Each was known by the name of its location, such as Norway, Great Britain, Liberia, or even Reunion Island. We can see the signal strength received from each of these transmitters and select which ones to use from the CDU's signal status screen. VLF reception is simulated with atmospheric effects, time of day, distance to the stations, and ionospheric bounce. While the accuracy of the position that we could get from Omega was not spectacular, when combined with nearby DME triangulation, the position estimate could be down to a few feet. From the moment you boot up the avionics, the system is trying to tune nearby ground-based navigation aids with several DME tuners at once. This is called row-row triangulation. Remember the radio remote tuning disable switch from a previous video? When that switch is off, we can also relinquish our primary VOR receivers to be automatically tuned from the nav radio page. This way, the system can also use row theta and theta-theta triangulation for better position estimates. We can monitor the position estimate produced by the FMS on the MFD's VLF Omega status screen and the position summary screen. While this position estimate is usually within operating limitations once the aircraft is off the ground, it may also degrade in areas with few DME transmitters or in conditions with poor VLF reception. If the position estimate degrades, the CDU will alert us with an appropriate message and prompt us to update the position estimate with a known location. There are 3 different methods to do this, including entering a longitude and latitude, a named fix, such as while on the ground at an airport, or by tuning a nearby VOR. Alternatively, the position can be updated while en route using the position hold function. Press this button only when directly over a known fix. When the button is pressed, the current position estimate of the FMS is held until you enter the name of the fix, thereby updating the position estimate. You can learn a lot more about position estimates and the Omega VLF network from the manual that comes with your Starship, and also from training videos from various sources online. I just wanted to introduce the subject to those who may have never considered what navigation at Flight Level 410 looked like before GPS constellations dotted the sky above. Until then, I'll see you in the next video.